All right, we are learning more about sum and difference formulas, and so we are going to get started here. The first thing I want you to do is find the exact value of this quantity right here. What you would be tempted to do is go to your unit circle, and for instance, to find sine at 65, you would go to 65 degrees, and you would find the sine value, which of course is opposite over hypotenuse, or y over r. But the problem is, if you're looking at your unit circle, you do not have coordinates at 65 degrees, so that is not going to help you. What is going to help you, though, is sum and difference formulas. And so, if you look at this, sine, it goes sine, cosine with a minus sign in between, and then cosine, sine. And so, what you're going to do is you're going to find a formula that's in the same format. So sine, cosine, minus in between, and then cosine, sine. You're looking at this formula right here. Notice that what you have plugged in for alpha is 65 degrees, and what you have plugged in for beta is 35 degrees. So I gave you the right side, this side of the equation. You're going to go back and give me the left side in order to be able to simplify this, okay? So you're going to say that alpha is 65 and beta is 35. So this is the formula for sine at 65 minus 35. And of course we can simplify that. 65 minus 35 would be 30. Okay. And then you're going to think about your unit circle, and I can't remember if I put one on here. I did not. You're going to think about what your unit circle is, and 30 degrees is over here. And at 30 degrees, your coordinates are root 3 over 2 and 1/2. Okay. And so your sine is your opposite over your hypotenuse, or your y value over your r value. So here's your handy dandy little triangle. Your y value, or your sine value, is 1/2. Of course, your hypotenuse is 1, so 1/2 over 1 will be 1 at 30 degrees. So the answer to that is simply 1. And moving on, same thing. This looks really complicated. You're going to be tempted to go to your unit circle, go to 25 degrees, find tangent. The problem is you don't have coordinates at 25 degrees or 35 degrees, so you need a different strategy. And of course, you're going to use sum and difference formulas. So you are going to find the formula that this looks very similar to. So it's a tangent plus a tangent, and then on the bottom sign it's a minus, which would be this formula right here. So this is the formula that you're going to use. You're going to simplify this. I gave you the right side of the formula, the part that's circled. You're going to simplify that, or replace it, and use the left side. So you are going to realize that this is the formula for tangent at alpha plus beta. Okay, so again, this is the formula for tangent. I'm going to just write this down, at alpha plus beta. In our case, alpha is 25 degrees, and beta is 35 degrees. And when I add 25 and 35, I get 60 degrees. And now this is a spot that I have coordinates for on my unit circle. Okay, so I want you to dig your unit circles out, and I want you to think about this. 60 degrees is up here. Okay, if you don't know your unit circle, you're going to need to dig it out. The coordinate at 65 degrees is 1/2 and square root of 3 over 2. Okay, if you're thinking about your little triangle, your triangle looks like this. Square root of 3 over 2 up, 1/2 over, and of course your hypotenuse is 1. Remember that tangent is your opposite over your adjacent. So your opposite, or your y value, is square root of 3 over 2. And your adjacent, or your x value, is 1/2. And then of course you'll flip it. And the 2's will cancel. And you'll get root 3. So tangent at 60 is root 3. And that is your final answer. Okay, then moving on to some kind of different ones here. Here you have to find exact values. I'm going to give you a bunch of information at 2 different angles on the unit circle, and an angle that's alpha and an angle that's beta. Okay, and you have to kind of think about this. So I'm going to worry first of all of the information I gave you about angle alpha. Okay, what I'm telling you is that the sine value for alpha is 4/5. Okay. This clearly is a positive number. Sine is positive. If you're looking at your unit circle, you know that sine is positive in quadrants 1 and 2. You're going to look for where on your unit circle sine is on the positive list. What I'm telling you is that your angle is somewhere between pi over 2 and pi? Well, here's pi over 2, and here's pi. So I'm telling you that angle alpha is somewhere between pi over 2 and pi. So I actually know that I'm in quadrant 2. Okay? So I'm going to think about angle alpha in quadrant 2. And I'm going to kind of draw a picture here. I know I'm in quadrant 2, so I know my angle has to look, or my triangle has to look something like this. And then I'm going to use what I know. So I know that my sine value is 4/5. And sine, remember, is opposite over hypotenuse. Okay, so I know that my opposite is 4 and my hypotenuse is 5, and I need to find my adjacent. Okay, so this is opposite or my y value. This is my hypotenuse or my r. And this right here is my adjacent or my x, and I need to find it. And if you don't know what it is, you're going to go x squared plus y squared equals r squared, or think of squaring those SOHCAHTOAs, okay? So I'm going to go 4 squared plus x squared equals 5 squared. So x squared will be 25 minus 16, which is 9. So x will either be positive or negative 3, and you need to decide. And that's why you need to know what quadrant you're in, okay? In this case, I am in quadrant 2, and I know that my adjacent in quadrant 2, or my x values in quadrant 2, have to be negative. So I know that that's actually negative 3 right here, and not positive 3, but it's negative 3, okay? So here we go. My x value was negative 3. My y value, or my opposite, was 4, and my radius, or my hypotenuse, is 5, okay? Right now, all I'm worried about is finding that information. That's all I'm doing with this right now. You'll see what you have to do on the next slide, but for right now, I need to know what my adjacent, my opposite, and my hypotenuse are at angle alpha. And I actually probably, it would have been helpful for me to put alpha in here instead of theta, okay? So there you go. All right, then. That was all the information I can get out of what I gave you for alpha. Now I'm going to go to beta. Okay, so I'm looking here at sine at beta, and I need to think about where beta is. I'm actually telling you that beta is somewhere between pi over 2, or pi and 3 pi over 2. Well, here's where pi is, and here's where 3 pi over 2 is. So I know that my triangle is going to be down here somewhere. So this is angle beta. And I'm not really drawing these to scale, but just so you know. Okay, sine, again, is opposite, or your y value, over your hypotenuse, or your r value. And the negative I know is there, and the hypotenuse can never, ever, ever be negative. So you know that that negative symbol has to go with the opposite. It can't go with the hypotenuse, because your hypotenuse can't be negative. So I know that this side right here is negative 2 root 5, and I know it's describing a negative distance, but it has to describe both distance and position. Your hypotenuse is 5, and then of course you're going to go x squared plus y squared equals r squared to get that. So this is x right here. So x squared plus negative 2 root 5 squared has to equal 5 squared. When you square negative 2 root 5, when you square negative 2, you get 4. I'm going to just kind of do this off of here. Negative 2 squared, and then root 5 squared. When you square negative 2, you get 4. When you square root 5, you get 5. And 4 times 5 becomes 20. So negative 2 root 5 is 20. Negative 2 root 5 squared, sorry, is 20. Equals 25. So then x squared equals 5. And x will be either positive or negative root 5. Okay, and again, you have to know what quadrant you're in to be able to decide that. So I'm down in quadrant 3, and my x values, or my adjacent values in quadrant 3, are negative. So this is going to be negative root 5 right here. Okay, so for angle beta, my y value is negative 2 root 5, my x value is negative root 5, and my hypotenuse is 5. Okay, so I've got all that information, and I'm going to use that in what I need to do next, okay? So I just carried that information that we found right here. This is nothing new. Nothing up in the green section is new to this problem. All we did was find our opposite, adjacent, and hypotenuse for each of our angles, for angle alpha and for angle beta, and they're different angles, okay? So now I'm asking you to use that information and to find cosine at alpha plus beta. And again, you're not going to be able to distribute. I want you to use your sum and difference formulas. So you need to know the sum and difference formula for cosine at alpha plus beta, which is of course right here. Cosine alpha cosine beta minus sine alpha sine beta. Okay, so cosine alpha cosine beta minus sine alpha sine beta. Okay, and now all you're going to do is you're going to plug in that information. Okay, so we know that when it says angle alpha right here, like right here, I need to use alpha's information. When it says angle beta, like it does right here, I need to use beta's information. Okay, so for the first one, cosine at alpha will be adjacent over hypotenuse at alpha. So adjacent over hypotenuse right here at alpha would be negative 3 over 5. Cosine at beta would mean I need to use this side over here. Cosine is still adjacent over hypotenuse, so negative root 5 over 5. And then sine at alpha, sine is opposite over hypotenuse. So sine at alpha would be 4/5. And sine at beta would be the y over the r, or the opposite over the hypotenuse, at beta. So negative 2 root 5 over 5. Okay? When I'm dealing with these two quantities right here, you're multiplying. Remember that when you multiply fractions, you don't worry about getting a common denominator. You just multiply across the top and multiply across the bottom. I know I have a common denominator already, but if I didn't, I would not need to worry about it. So on the top, negative 3 times negative root 5 would be positive 3 root 5. And on the bottom, 5 times 5 is 25. Minus, and then on the top here, negative 8 root 5 over on the bottom, 25. Okay, now I'm subtracting fractions, and I do need common denominators when I'm subtracting fractions, which luckily I have. So since I have common denominators, I can just change this to 3 root 5 minus negative 8 root 5, which of course becomes plus 8 root 5, all over my common denominator, which is 25. And if I add 3 root 5s plus 8 root 5s, I get 11 root 5s over 25. And some people ask me, can I cancel that 5 or reduce the 5 with the 25? And no, you can't, because the 5 is inside the radical and the 25 is outside of the radical. And that is all I can do on this problem. Okay, same problem, part B here. Same information, the part in the green, nothing has changed on the part of the green, not one thing. Okay, so we're still working with the same two alphas and betas. On all that information is the same. Okay, so moving on, now I'm needing you to find tangent at alpha minus beta. Again, you're not going to distribute. Okay, can't do that, but you are going to use this handy dandy little formula right here. Tangent at alpha minus tangent at beta over 1 plus tangent at alpha times tangent at beta. So I'm going to just write this out. Okay. And now I'm needing to plug some information in. Okay. So tangent at alpha would be my y over, or my opposite over adjacent, or my y over my x, at angle alpha. And again, if it says alpha in the formula, then you need to use alpha's information. Okay, so tangent at alpha would be opposite over adjacent at alpha. So 4 over negative 3 minus tangent at beta, so I'm going to use this information, and tangent at beta would be opposite over adjacent there, so negative 2 root 5 over negative root 5. Okay. And you really should probably have these simplified before you plug them in, but I'll talk about that in a minute. All right, and then tangent at alpha again is negative 4/3. And tangent at beta, let's talk about this. I should probably have simplified this before I actually plugged it into the formula, so I'm going to do this off to the side. Negative 2 root 5 over negative root 5. Okay? Well, clearly a negative over a negative is a positive, so I'm not worried about that. And some of you are looking at this going, oh my gosh, I have radicals in the denominator and I have to conjugate it. And some of you will go like this, which is totally fine. That works. And you would get 2 times, oops, the square root of 5 times the square root of 5 on the top. right here, the square root of 5 times the square root of 5 is 5. And on the bottom, the square root of 5 times the square root of 5 is 5. And then 2 times 5 is 10 over 5, which is 2. Okay? Totally doable. Long way, though. That was a long way. But if you don't recognize this from the beginning, that's fine. The other thing when you do tangent is if you have this, don't make it harder than it needs to be. Negative over negative is a positive. And then root 5 over root 5 are just going to cancel. Okay? So you get 2 there. So don't make that harder than it needs to be. And let's not plug in that ugly quantity. Let's plug in 2 instead. Okay? All right, and then it would be plugged in 2 here. 2 would be plugged in there as well. Okay, so now on the top, I have negative 4/3 minus 2 over 1. And then negative 4/3 times 2. You always have to multiply before you add and subtract. So I'm going to make this over 1. And I don't need common denominators when I multiply, so I would have negative 8/3 right there. Okay. Now I'm going to get common denominators though, so this 2 right now is 2 over 1 and this 1 is 1 over 1. So I need to multiply this by 3 and make this be 6/3 instead, and make this be 3/3. So on the top, when I have negative 4/3 minus 6/3, I have negative 10/3. And on the bottom, 3/3 minus 8/3 is negative 5/3. And then, instead of dividing by that fraction, I am going to multiply by its reciprocal. A negative times a negative is going to be a positive. The 3's are going to cancel. The 5 is going to become a 1. The 10 is going to become a 2. And your final answer is 2. All right, so this should be your homework for the day, and hopefully it will go okay.